All right, I'm going to solve some of the questions that I've been asked to solve. So this is exercise 8.2 and question 2B part V or 5. So two dice are thrown and the product of the two numbers is recorded. So remember the word product means multiplication. So if I've got two dice, obviously there are 6 options. 1, 2, 3, 4, 5, 6. And so I have 36 different possibilities. That's the whole sample space, right? Everything I can get. So I'm looking at the product, and this says that the product is a prime number. So I'm not going to write all of these things out, but if I'm writing product of everything that is a prime number, remember 1 is not a prime number, 2 is, 3 is, so is 5. So let's keep going here. Here's a 2, here's a 3, here's a 5. All right, 2 times anything is not going to be prime, is it? Because it can always be divided by 2. What else have I got in here? Nope, those are all fine. Okay, so this is all I've got. So that means I have 6 different prime numbers that are products. So there are 6 prime numbers out of a total of 36 prime numbers, 36 total options. Simplify my fraction, I get 1/6. So the probability that the product of 2 dice being thrown being a prime number is 6/36 or 1/6. All right, the next one I was asked about is exercise 8.3, question 2B again. Apparently we don't like 2Bs. All right, so this time I have 12 balls. I have 5 red ones and the rest are blue, which means that there are 7 blue ones. So now I'm being asked the probability that the 2 balls are a different color. Okay, so what I'm doing, I am drawing 2 balls. So it says it is replaced and the second ball is drawn. So we've got replacement. So what I'm going to do is I'm going to draw a little tree diagram. I could either get a red or a blue. And then my second time, I could also get a red or a blue or a red or a blue. And now on my arms, I'm going to write the probabilities. So the probability of getting a red is 5/12. Probability of getting a blue is 7/12. Same over here, 5/12, 7/12, 5/12, and 7/12. So I want the probability that the 2 balls are a different color. So I'm going to have a look at my little arms and see when that happens. Here I get a red and a blue, so this arm is good. And here I get a blue and a red, so this arm is good. So now I'm going to work out the probability that this branch happens. So I need a red and a blue. Remember the word and means multiply, and the word or means add. So I need this and this. So I'm going to say 5/12 times 7/12. And all I do is multiply straight across the top and bottom. So I get 35/144. Same with this, isn't it? This is 7/12 times 5/12, which is, of course, the same answer. Now, if I want one of each color, I am allowed to have this branch or this branch. So I'm going to take my probabilities, I'm going to add them together, plus another 35. All together, I get 70/144, and then I can just simplify my fraction, which gives us 35 out of, what's half of 144? 50, 22, so 72. All right, so that would be how you would do this question. So what you want to do is work out all the things that you're allowed to have separately, and then if you're allowed to have more than one thing, you add those things together. All right, that's 8.3. Now let's look at the crazy question from the past paper section. So I'm now on page 172. So I'm going to look at question 4. This is the one with the dartboard. So I'm just going to draw this stuff because I think it would be easier to see if I draw it. Okay, draw it. Well, this is not going to look so great, is it? Okay, so then I have the numbers 20, 10, and 5. So, whoops, nope, I don't want to draw. So 20, 10, 5, and obviously if you miss, you get a 0. So the probability scored, we have the score of 20, 10, 5, and 0. And we're told that this is 0.2, 0.3, 0.45, and we have to work out this one in part A. Obviously, all probabilities always have to add to 1 because it's 100% of everything that could happen. So that means that this is 0.05 because this is 0.2 plus 0.3, which is 0.5. And then 0.5 plus 0.45 is 0.95. So this is what's left. So here are all my probabilities. So for part V, which is the one I was asked about, part 5, I am being asked, sorry, that's not what I was asked for C, question I. So C, I is the one I was asked about. Okay, so Kaya throws a coin 2 times. So calculate the probability that she scores a total of 15 points with her 2 throws. Now, I did actually draw this on the board. Well, other people were drawing it on the board today. I think I drew it the other day. This can be a really crazy tree diagram. So what I can get, I'm going to think about, I can get 4 different scores, right? My 4 different scores are 20, 10, 5, and 0. And then I can do that again, right? So each time, because I'm throwing it twice, I have 4 more possibilities. Now, I want every arm, so there's 20, 10, 5, 0, 20, 10, 5, 0, 20, 10, 5, 0, 20, 10, 5, 0. I want all the branches where I can get a total score of 15, right? That's what it says. Yes, 15. So obviously nothing here is going to work because I'm already over it with 20. So I don't want any of these options. I can get 10 and 5. So this is an option I can have. I can have 5 and 10. This is an option I can have. And I'm not going to get any 15s with this either. Is it 2 throws or 3 throws? Yeah, 2 throws. So these are the only 2 branches where I can get a total score of 15. So what I'm going to do is the probability of getting a 10 is 0.2, looking up here. Probability of getting a 5 is 0.3. 5 is 0.3, 10 is 0.2. So here I have 0.2 and 0.3, right? I want both of these things to happen. Same with this. So then I've got 2 branches that I'm allowed to have. So 2 times 3 is 6. And then if I want this branch and I can have this branch or this branch, they're both allowed to happen. I'm going to add them together. So then that would be the probability that I get a total score of 15. All right, I hope that helps. Please let me know if you need any more assistance.